The electromagnetic spectrum describes various forms of energy that travel in waves. So that's the similarity between them. And if we look at this spectrum in the image here, we can see that there's a variety of energy forms that do travel in waves. And we can talk about radio waves, microwaves, gamma rays, etc. But the part that's going to be the most interesting to us for biology is going to be this section in the middle, which is called the visible spectrum. When we talk about the visible spectrum, that is what we typically think of as light. And light itself is made up of a lot of different colors. Now, if we take a step back and we talk just a little bit more about the electromagnetic spectrum generically, a wavelength is going to be from the top of one wave to the top of the next. So that's the distance that we call a wavelength. And a lot of times we designate that with the Greek symbol lambda. Okay, so that would be a lambda there. And so if we look at this end of the spectrum over here, these have very short wavelengths, and we get shorter the further over we get in that direction. And then over on this end, we have very long wavelengths. Okay, so longer wavelengths over here, shorter wavelengths over here. Visible light is going to fall kind of right in the middle at kind of a medium wavelength. The importance of this is that the wavelength is going to be inversely related to the amount of energy that is there. So as you can see, the shorter the wavelength, and I'm going to use lambda again to represent that, but the shorter the wavelength, the greater the energy packed into that particular wavelength. So we do have this inverse relationship between the two. It's very important to understand that part right there, that as we get shorter in wavelengths, the energy gets higher. As we get longer in wavelengths, the amount of energy gets lower. And that's why when you look at this spectrum, the things that you see on this end with the short wavelengths, those are what we tend to think of as dangerous things. Okay, so X-rays and things. And that's because they pack a lot of energy. So if they strike particular molecules or cells, they can cause a bit of damage because of the amount of energy they contain. Over here on this end of the spectrum, we have much longer wavelengths. And so things like radio waves and microwaves, we think of these as harmless. That's not to say that there's no energy packed into those, but the energy is going to be much, much less. So these are not going to be so damaging when they actually hit something. When we talk about light energy, that is what we call the visible spectrum. And light energy runs from having a wavelength of about 400 nanometers up to about 700 nanometers. And within visible light, we think of it as white light, but there are a lot of different colors in there. If you've ever used a prism, you've probably seen those colors separated before, and that's essentially what we're seeing if you ever look at a rainbow. Now notice that the different colors of light do have different wavelengths, and again, there was an inverse relationship between the wavelength and the amount of energy that they contained. So over here on the purple and blue end, these are going to have higher energy than over here on the red-orange end. So these would have lower amounts of energy.